Namaste, Sati students. I'm Priyanka Rajeev from Department of Mechanical Engineering, IIT Kanpur. So this is lecture 5 of laws of motion. And today we'll be continuing the discussion on reaction force and acceleration from free body diagram. So we were discussing how to find the reaction the acceleration and normal force from the forces that is acting on the object. So now we will see one example problem where you have to find the force from the acceleration given. So you can see the diagram given here. So this is a 5 kilogram block on an inclined plane at an angle 37 degree. And it is given that this block is moving upwards with an acceleration of 2 meters per second. So we have to find the force acting on this block. So for this, we have to first make a free body diagram. So you can see that this is the free body diagram of the block. Okay, so this is a block, and we have to draw the forces that is acting on this block. So this is the inclined plane here. So the angle here is what? 37 degree. Now we know that the weight of the body will act vertically downwards, which is equal to here it is 5 kg. So 5 times g, if we will take it as 10, so that is 50 Newton. Now we have to see that this force which is given here is acting parallel to the inclined plane. So we will draw it over here, and we know that because of this contact with this inclined surface, there will be a normal reaction perpendicular to the surface, right? The contact surface. So we have to draw the normal reaction right now. So that is like this. Now we want to find the force F, right? So for that, we will resolve this force F into its components, which is like one is perpendicular to the this is the xy plane we have. So we want to find the components of F in xy plane. So this is Fx and Fy. So how to find that, we'll see right now. So this is the horizontal plane that we can take as a reference. So we want to find a component parallel to this horizontal plane. So for that, we will resolve this like this. So one is like this, and the another one will be like this, right? So how to find now? If this angle is 37, once again, sorry. So here we want to resolve this weight into its components, like one is perpendicular to the plane and another is parallel to the plane. So how to do that? So this is 37 degree. So this will be 50 sine 37, and this will be 50 cos 37 degree. So now we can equate the vertical components and horizontal components. So first, equating vertical components, we will get n equals 50 cos 37 degree. So we know cos 37 is 4 by 5, and so 50 cos 37 is 40 Newton. And equating the horizontal component, we know that there is an acceleration over here. So that is like 2 meter per second, right? So acceleration is A equal to 2 meter per second square. So here we know net force is equal to mass times acceleration. So net force is F minus 50 sine 37. Why we have subtracted this 50 sine 37 from F? It's because this object is moving upwards. So it is moving along the direction of the force acting, the external force acting, that is F. So that means F is larger than 50 sine 37, the weight component along the inclined plane. So that's why we are writing it like this. And that is equal to M is 5 and acceleration is 2. So now simplifying, we will get F equal to 5 times 2 is 10 plus 50 sine 37. So 50 sine 37 is 3 by 5. So you will be getting 10 plus 30, that is 40 Newton. This is how you find the normal reaction and the force, external force given, applied if acceleration is given. So now next question is to find the normal reaction at points A and B if mass of the sphere is 10 kg. So have you ever seen such a setup? It is equivalent to something like a vernier caliper where you use it for measuring the diameter of a spherical object, right? So this is something similar here. So how to find the normal reactions here? So the main important point is you have to remember that normal reaction always act perpendicular to the contact surface. So if this is the contact surface here, then it will act perpendicular to the contact surface. Okay. So this is perpendicular to the contact surface. So here also it will act perpendicular to the contact surface, right? So we will take this normal reactions as NA and NB. Now we want to find the angle at which it is inclined. So for that, some geometric parameters are given. For example, you can see that here this distance is given. This is 3 meter. This is 1 meter. And this radius is 5 meter. So let's draw it over here. So here you can see that this triangle, if we consider, this is the radius, right? So this is R, and you want to consider this right triangle. So how? So you want to. So how are we finding this length? So this is 3 plus 1. So this is 4 meter. Okay. So because this whole thing is 5 meter, this whole length is 5 meter because it's radius, right? From center to the point on a circumference. So here you can see that this distance is 1 meter. So 5 minus 1 is 4. Now you want to find the angle theta over here. So how to find that? So you can see that the right triangle drawn is like this. This is 4, this is 5, and this is theta. So this sine theta is 4 by 5. So theta is sine inverse 4 by 5 is 53 degree. Okay. So this is one angle that we got. Similarly, we want to find for the other angle too. Okay. So how to find it? So here again, if you are drawing to this contact point, this is the radius again. And we want to find this length. Okay. So this is what? This is, you can see this length is this length for this contact point. So this is 3 meter. This is 5 meter. So the right triangle drawn here is like this, 5 and 3. So what is this angle? This is sine theta equals 3 by 5. So theta is sine inverse 3 by 5, which is equal to 37 degree. Now, we want to draw the free body diagram. So consider this is a sphere. Then there is this A and B over here. So this NA is acting along this direction. So this is NA. And from here, NB is acting. So this is NB. And another important thing is the weight of the sphere, that is 10 kg. So 10 kg times the gravity, that is like 100 Newton. Right. And the angle at which it is acting is, if we consider this as horizontal plane, this angle we have found it is 53 degree. And this angle is 37 degree. So now we have to resolve this into its components. So NA, if you are resolving into perpendicular and horizontal and vertical components, it is NA cos 53, and this is NA sine 53. And for NB, how will it come? It will be, okay, it will be like this, and along this vertical again. So that is like NB sine 37 and NB cos 37. So now we have to equate these forces, like its horizontal components and vertical components. We can equate. How we can equate? It's because it's in the rest position, right? It's not moving. So there is no movement in X direction nor in the Y direction. So we can, that's because the net force acting on it is equal to 0. That means, the forces are cancelling out each other. So you can see that when we equate the vertical components, it is NA sine 53 degree plus NB sine 37 degree equals 100 Newton. That is equation 1. And horizontal, it is like NB cos 37 degree equals NA cos 53 degree. Now that is equation 2. Equation 2. Now NB equals NA cos 53 is what? Cos 53 is 3 by 5. And cos 37 is 4 by 5. So this will cancel out each other. And this will become NB equals NA 3 by 4. So this is equation 3. Substituting 3 in 1, you will be getting NA sine 53 is what? Sine 53 is 4 by 5 plus NB sine 37 is, so NB you can write it as NA 3 by 4, and this 37 you have to write it as 3 by 5 equals 100 Newton. You can easily solve for NA. So how to solve for NA? So in 4NA plus 9NA equals, so you have to take it like, 9NA by 20 and 4 Na by 5 equals 100 Newton. So this you have to make LCM same. You have to take LCM and make the denominator equal. So that is like you have to multiply it by 4. So that is 16 Na plus 9 Na equals 100 times 20. So this is 25 Na equals 100 times 20. Na equals 80 Newton. So if you found Na, then you can find Nb. So from equation 3, that is Nb equal to Na times 3 by 4, that is equal to 80 times 3 by 4, that is equal to 80 divided by 4 is 20. So 20 times 3 equal to 60 Newton. So these are the reaction forces. I hope you understood this problem, like how to find the solution. The key point here is reaction force is not always in the y direction. Okay, it's not like whichever orientation it is, it's always like this. No, it is reaction force is always perpendicular to the contact surface. So here the contact surfaces were like this. So the reaction force is perpendicular to the contact surface. So that's how we got this, and how to find the angles. I hope you understood this, because the measurements were given from the diagram, and you have to find the angles from that diagram. Now here there is this another interesting theorem. So that's called Lamy's theorem. So Lamy's theorem says when three forces are acting at a point and are in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Okay, so here you can see this, we were taking it as, okay, 1 second. Here you can see this is Na, Nb, and the weight of the body. So if you equate this forces into Na, and this as Nb, and this as weight of the body, then you can easily find the angles, right? So how it was? So this was a horizontal plane. Actually, this orientation is wrong, so I'll draw it over here again. So it was like here it was 53 degree. So if we consider this horizontal plane, this was like 37 degree. So this is Nb, this is Na, right? Is Na, Nb, and 100 Newton was acting downwards. Okay, now if you want to see the angle between Na and Nb, you have to take the angle between Na and Nb. That is like 90 plus 53, that is equal to 143 degree. So this is like 180 minus 37 minus 53. So that is like 90 degree. Okay. And this is 90 plus 37 degree. That is equal to 127 degree. So now if you want to write it here, so this is the equation. So here A equal to, so you're taking this as A, B, and C. So A is equal to Nb, B is equal to Na, C is equal to 100 Newton, and angles are alpha is the angle between B and C. Like what is opposed to A, that is alpha. What is opposed to B, that's beta. And what is opposed to C, that is gamma. Okay, so alpha equal to what is opposed to A, 90 plus 53, right? This is 143 degree. And what is opposed to B? Beta angle. Beta angle is 127 degree, and gamma angle is 90 degree, right? So you have got all the values. You have to now find the reaction forces NB and NA. So how to find that? A by sine alpha. So that is NB by sine alpha is sine 143 degree equals N. So B by sine beta. B is NB, NA. NA by sine beta is sine 127 degree equals C by gamma. Gamma is sine 90. So C here is what? 100 Newton by sine gamma is sine 90 is 1. Right. Now you have got a constant and you have got some ratios. So you can just equate it directly. One equation will be like NB sine 143 equal to 100. Equation 1, and NA sine 127 equal to 100. So there is no it's very easy here, right? You don't need to resolve this NA and NB into its components and calculate it. You can directly get the values. So how to find NB? NB equal to 100 times sine 90 plus 53. So sine 90 plus 53 is cos 53. 100 times cos 53. So cos 53 is what? Cos 53 is 3 by 5, right? So 100 times 3 by 5. And here NA equal to 100 times sine 127. So this is how you do calculate the reaction forces here. So this is an alternative, because this Lami's theorem can be applied only when three external forces are acting at a single point, and the object after this application of external forces remain at equilibrium. That is, it won't move in X or Y direction. So now the next question is more than one block problem. So how to find the forces acting on 2 blocks or 3 blocks or 4 blocks. So how to calculate this this kind of like the reaction forces between these 2 blocks, or the acceleration of this entire body. Okay. So first what we have to do is, for finding acceleration, we have to consider these 2 blocks as one system, because this force is trying to push both the blocks, right? So let's consider this 2 blocks as a single system of mass m1 plus m2. Okay. Then drawing the free body diagram, it will be like this. F is acting, weight of the body is acting, m1 plus m2 times G is acting downwards, and the reaction force is acting upwards. So N and m1 plus m2 G will cancel out each other, because there is no movement in Y direction, in the perpendicular direction or the vertical direction. There is no moment. And in X direction, what will happen? Net force is equal to mass times acceleration. So what is the mass here? m1 plus m2, and acceleration is a, and net force is F in horizontal direction. So acceleration equal to F by m1 plus m2. Now we want to find the reaction force. So you know that as soon as these 2 blocks come into contact with each other, these 2 blocks, this block will exert a force on this block, that we can take it as R21. That is like the force exerted on 2 by 1. And this block will, like M2 will exert a force on M12, right? So that is R12. These are action reaction pair. Okay. So now the free body diagram of M2, if we consider, we have to consider the external forces that is acting on M2 alone. Okay. So what are the forces acting on M2 here? So F is actually being acting on M1, right? So this is on M1, F is on M1, R2 is on M1, and sorry, this is not R2, this is R12. Okay, R12. And so only force that is acting on M2 is R21 in horizontal direction. So R21 is acting on M2, and there is this weight of M2 is acting, and there is this reaction force is acting. So these are the things that is these are the external forces that is acting on M2. So now we have to find the reaction force R21, right? So this reaction force is what is pushing this M2 with an acceleration of A, right? So we have found A here. So what is A? A is F by M1 plus M2. So the reaction force R21 is equal to M2 by M1 plus M2 times F. Okay. So this is how you find the reaction forces between two blocks. Okay. So similarly, to check if this is right, you know that if R21 is this, then R12 should be equal and opposite to R21, right? So let's draw the free body diagram of M1. So M1 is this, and the external forces acting on M1 are, so you can see, one second, something got stuck. Okay, so external forces are this F is there, and R12 is there, and the weight is there, right? So we will draw this external forces. One is F, and another is R12, and this is going at an acceleration A, and this is reaction force and weight of the body M1G. Okay. Now to find R12, we know that. So this body is moving along F direction, right? So this should be a larger force. So you have to take F minus R12 is equal to M1 times A. So that is how we consider the force and acceleration equation, right? So net force equal to mass times acceleration. So what is the mass here? So this is free body diagram of M1, FBD of M1. Okay. So net force is F minus R12 equals mass is M1 and acceleration is F by M1 plus M2. Okay. So now we want to find R12 over here. So R12 is equal to, so if we take it to this direction, R12 to this direction, and this entire term to this direction, this is like F minus M1 times F by M1 plus M2. Okay. Now this F has a coefficient of 1, right? So you have to multiply M1 plus M2 and divide by M1 plus M2 to F, and here it will be like m1 times f by m1 plus m2. So now what will happen? This m1 times, so this can be expanded as m1f plus m2f minus m1f by m1 plus m2, right? So this m1f and m1f will get cancelled. So now we have what? m2f by m1 plus m2, right? So we got the reaction forces m2f by m1 plus m2. So this is equal, right? Now direction, to show the direction, we will put the negative sign because it's acting opposite to R12. So this is how you get the reaction forces when there is a force acting on two blocks which are kept together. Okay. Now we will see an example with three blocks. So how to find the reaction force between three blocks that are kept together when a force, external force F is acting on them. So you have to find, we will keep the objective as one is we will find the acceleration of system, then we will find the reaction between m1 and m2 and reaction between m2 and m3. So how to find this? So first we have to find the acceleration of system. For that, we will consider this whole system as a combination of three masses together, that is m1 plus m2 plus m3. So for that, we will draw a free body diagram with three masses together, m1 plus m2 plus m3. So for this, the free body diagram will be like this. So this weight of the object will act downwards. So m1 plus m2 plus m3 times g will be acting downwards. There is a reaction force N, normal to the surface. So that is N. Now we want to see the acceleration, right? So this F is acting on the system towards the right direction. So acceleration is, so in vertical components, N equals m1 plus m2 plus m3 times g. So we got the normal reaction. We are not concerned about that now. We have to equate the horizontal forces. So in horizontal direction, what is happening? Net force equal to mass times acceleration. So net force here is F. Mass is m1 plus m2 plus m3 times A. So A equals F by m1 plus m2 plus m3. Right. So this is the acceleration of the system. So all three blocks are moving with an acceleration of F by m1 plus m2 plus m3. Okay. Now we want to see the action-reaction pairs. So we will do one thing. The reaction forces between m1 and m2, we will take it as R1. And the reaction force between m2 and m3, we will take it as R2. So this is R1. And there is another reaction force that is also R1 here. So R1, they are acting as action-reaction pairs with the magnitude of R1. So actually, okay, to reduce the confusion, I will write it like this. So first, this is R21, that is the reaction force on 2 due to 1. So, okay, and this is R12. This is like reaction force on M1 due to M2, right? So that I will write it as R21 equal to minus R12 which is equal to the magnitude of both are R1. Okay. Now we can write this as R1 and this is also as R1. We are just talking about the magnitude here. The direction we know that it is equal and opposite, right? Now here also again we will see the reaction forces. This is R32 and this is R23. So R32 and R23 are equal and opposite. So equal in magnitude and opposite in direction. So the magnitudes we will take it as R2. So that we can write it as R2 over here and R2 over here. Okay. So now we have seen the reaction forces over here. Now we have to draw the FBD of any one of the blocks here. So we will take the FBD of M3 right now. So FBD of M3 is like this. FBD of M3. So this is the block over here. This is M3. So we are only concerned about the horizontal force. Okay. Still we will write the normal forces over here. So this is M3G and this is N3, the reaction force on block 3. And here there is only one reaction force on this block, that is R2. So how we will explain it once again. So this reaction R2 is acting on M3, right? This R32 is acting on M3. On M2, this R1 and this R2. So R21 and R23 are acting. That is R1 and R2 is acting on M2. And on M1, this F and this R12 are acting. So that is R1 and F. So that's why I'm saying on M3, only horizontal external forces are 2. Okay. So R2, we will write it over here. Okay. So this R2 is causing the horizontal motion of M3 with an acceleration of A. Okay. So vertical, we know that we have to equate it like this, because there is no vertical motion. So the forces will cancel out each other. So they are equal in magnitude and opposite in direction. So N3 is this. For horizontal component, we know net force equal to mass times acceleration. So net force is what? R2 is the net force. Mass is equal to M3 and acceleration is what? It is given here, right? Acceleration is F times F divided by M1 plus M2 plus M3. So this is the reaction force R2. Okay. So R2, we know the magnitude is the same. So R32 and R23 equal to R2 is equal to, here we will write the final result, that is M3 F by M1 plus M2 plus M3, right? So we got R2. Now we want R1. So R1, how to find R1? So we will take the free body diagram of M1. M1 we will consider. So this one we will consider. So FBD of M1, we can draw it like this. So this is M1. There is this weight of M1 acting downwards. There is this reaction force of M1, that is N1, acting upwards. There is this force, external force that is being applied on M1. You can see that over here. So this is the external force acting towards right, and this is the reaction force from M2 acting towards left. So they are in opposite direction. So you can draw it like this. This is F is there, and there is this R1 is acting opposite to F. Okay. Now to equate, you can see N1 equals M1G because there is no movement in vertical direction. And horizontal, if you are equating, you can you know that the acceleration is in this direction along F. So that means F is the larger force over here. So you have to write net force equals to mass times acceleration. So net force is F minus R1. Why we are subtracting R1 from F? It's because the acceleration direction is along F direction. That means the F force is larger than R1 force. And so F is greater than R1. So that's why we are subtracting the smaller one from the larger one. Then mass is M1 and acceleration is what? F times F by M1 plus M2 plus M3. Right. So now the way we found out the reaction force before, you have to take R1 to one side and F to the other side. So F minus M1 F by M1 plus M2 plus M3. So you have to multiply and divide by M1 plus M2 plus M3 to F minus, this. Okay. Okay. So this is the reaction force R1. Now you can expand this thing. So M1F plus M2F plus M3F minus M1F is equal divided by M1 plus M2 plus M3 is equal to R1. So this M1F and M1F gets cancelled. So you can see that M2 plus M3 times F divided by M1 plus M2 plus M3 is the reaction force R1. Okay. So you got R1 and R2. So those are the only. So this is the reaction force between M1 and M2 is what? R1. And this is R2. We got the two reaction forces and the acceleration of system. Okay. Now there's a shortcut to find these reaction forces. So how to find that? So this shortcut is only applicable for forces that is acting only from one side, okay, not on the both sides. So this is only for one side force. So this is the first problem that we discussed. So this is F. So this is the only external force that is acting. So it can be from either side, okay. It can be from the this F can act from this side, or it can be from this side, but it should only be from one side. It should not act on both sides. Okay. So how to find this thing? So acceleration, you know, net force equals mass times acceleration, and force is equal to here M1 plus M2 times A, and A equal to F by M1 plus M2. So you got the acceleration of the system. Okay. So now you have to find the reaction force. So how to find the reaction force here? This R here. So you can see that R is the force that is pulling M2 with the acceleration A. So this acceleration, you can just substitute F by M1 plus M2. Okay. I hope you got the pattern lying behind this thing. So as soon as you see a system of 2 blocks or 3 blocks, you can immediately recognize what is the reaction force. So reaction force acting on this object will be proportional to the second mass. Okay, M2 is here. So that is one thing. And so whatever force is acting on the block, the second block will be getting the deciding the reaction force strength. So this M2 is less. That means reaction force will be less. So that you can understand, right? So how to intuitively understand this is, suppose you are standing in a queue. Okay, standing in a queue. So it's a very crowded place. Okay, so you're standing in a queue, or you went for a concert. Okay, so you're a 10-year-old child. Okay, and here there is a 40-year-old man standing here. Okay, 40-year-old is like almost like 10-year-old child will be 30 kg, 40-year-old man will be 80 kg. Okay, so if you are being pushed from another person behind, so this person is like maybe 15 years old. Okay, 15-year-old, so 40 kg mass. So this person is pushing you. Okay, F weight is there. So you will get in contact with this person, right? So this person is what? This person is heavier than you. Okay, this is M2. M2 is 80 kg. M1 is 30 kg. Okay, this we don't need to consider this mass because we are only interested in this force F. Okay, so this child is getting pushed with a force F, and the second person standing next to him is him or her is 80 kg. So 80 kg mass is like huge, right? Compared to this child, 80 kg is larger or greater than 30 kg. So this child cannot, if this child is like 5 meter apart from this person, so if he is getting in contact with this fellow, this 40-year-old fellow, so that means he's moving 5 meter, right? But as soon as he comes into contact with this person will just move like maybe 2 centimeter, because this person is not experiencing that much force compared to this child. Why? Because he's heavier. So that means the reaction force given to this child is larger. So F minus R is what is acting on this person, right? So F minus R is what is acting on the second person, this 40-year-old man. So I'll write it once again neatly. So you can see that there is this child of 30 kg and there is this man of 40 kg, sorry, 80 kg. So this is M2 and this is M1. Okay, and this child is getting pushed with a force F, and this child will come into contact with this man, okay, soon. So when he comes into contact with this man, he exerts a reaction force. Okay, he will exert a force on him, that is R, and this child is also exerting this man will also exert a force R on this child. Okay, so this man is experiencing F minus, sorry, this man, okay, so this child will, what will happen? So the reaction force will be calculated by M2 times F by M1 plus M2. Okay, so this M2 is larger means reaction force is larger. Reaction force is larger if M2 is larger, right? So what will happen is this child will experience a force F minus R as soon as it comes into contact with this man. So F minus R will be, the magnitude will depend on R, right? Sorry. The magnitude will depend on R. So if R is larger, the child will stop immediately. Otherwise, the child will get pushed more, right? If suppose this child was in contact with a 2-year-old kid or 5-year-old kid. So this is like, this child is 30 kg and there is another child that is like 15 kg. And so this child is getting pushed by F, and it comes into contact with this child soon and exerts a force on R, and this child will also experience a force R. And since the mass of this child is less, so M2 is less here, and the reaction force is in the second case will be lesser than the first case. Okay, so what will happen here is, this first child, 30 kg child, will experience F minus R here. That will be smaller, larger than the first case, because R is smaller. So F minus R is going to be large in the second case. This is case 2. This is case 1. So case 1, the child is experiencing F minus R. So we will take it as net force 1. So this is net force 2. Here, this net force 2 will be greater than net force 1. So what will happen? This force will push this first child and second child, and they together will go and push a third person and fourth person and so on, and the crowd will suddenly start stumbling on each other. But if this is a man over here and he is heavier than the first person, what will happen? This F minus R is less, so this child will eventually go a lesser distance. That means the second person, third person, etc., they will be experiencing lesser force, so it will be much more stable. So that is how this crowd is like pushing, and some people falls down and severe things will happen. So these are all can be explained with this kind of free body diagram. Okay. So another shortcut is for the third 3-block problem also, we can try to apply this shortcut over here. So what is going to happen? So here again you have seen there is this reaction force R1 acting between M1 and M2, and R2 acting between M2 and M3. So this is the you can just apply net force equal to mass times acceleration. So what is the mass here? M1 plus M2 plus M3. So net force is F over here. So that is equal to A. So A is F by M1 plus M2 plus M3. Okay. Now reaction force you want to see between what? If you want to calculate R1 is going to push what all force masses. You can see that R1 is the force that is acting on this two system combined. So you can consider M1 to be one system and M2 plus M3 to be another block. Okay. So this R1 is going to push M1, M2 plus M3. Right. So what is the mass over here? M2 plus M3. What is the acceleration over here? Acceleration you have found already. So that is F by M1 plus M2 plus M3. Similarly, to find R2, what will you do? You will consider this M1 and M2 together and M3 to be another system. So this M1 plus M2 is providing this R2 reaction on M3, and that is pushing M3 to accelerate with the acceleration A. So that is M3 times F by M1 plus M2 plus M3. Right. So it's very easy now, right, to see it as a you can disintegrate this problem. You can analyze this problem by interpreting it as uh, different systems, and you can find the reaction force easily. If you are taking these three blocks as independent blocks and resolving it and finding, then there will be much more complications. Here it is much more easier, right? So you just for finding R2, you don't need to think about R1 or the gap between M1 and M2. You just think about M1 and M2 together, and there is this one force which is acting external on M3, that is R2, provided by M1 and M2. So this R2 is providing an acceleration A on M3. So A is already found. Thinking of this whole three blocks as one single system, so you equate that A to A in this R2's equation. So that is how you find R2. So R1, this in the similar manner how we are doing, M2 and M3 is taken together. So M2 and M3 is being pushed by R1. So the mass here is net force equal to mass times acceleration. The mass here should be considered as M2 and M3, M2 plus M3. So M2 plus M3 is being pushed by R1 with an acceleration of A. So that A is again calculated using this formula. So that A can be substituted here, and that is how you find R1. So if you consider a block of 4, how to find the reaction forces? So here, how many reaction forces will be there? So one is like R1. Okay, R1. Then there will be R2. Okay, and there will be okay. So I'll just take it like this. There will be R3, right? So that is how. So this is M1. This is M2, M3, and M4. This is a force here, F. Everything is in contact, okay? So what is going to happen? So if you want to find R1, what will you do? R1, how will you find? So you have to first find the net force. So F equal to, what will you do? M1 plus M2 plus M3 plus M4 times A. So acceleration is F by M1 plus M2 plus M3 plus M4. Okay, that is one thing. So acceleration is found. That is very easy. Now R1 is going to push what all blocks? So M1 is here, and there is this M2 plus M3 plus M4 is taken together, and R1 is going to push M2 plus M3 plus M4, and it will be going at an acceleration A. So R1 equal to M2 plus M3 plus M4 times A. So how to find A? Just it is already given here. So substitute that A over here, M2 plus M3 plus M4 times A is F by M1 plus M2 plus M3 plus M4. So similarly, R2, what you will do? R2 is M1 plus M2 is over here. M1 plus M2 is over here. And here is a block of M3 plus M4. And R2 is being provided by M1 plus M2. And that is pushing M3 and M4. So R2 equal to M3 plus M4 by M1 plus M2 plus M3 plus M4 times F. Similarly, R3 will be what? Only one block will be pushed here, M1 plus M2. Okay, wait. M1 plus M2 plus M3. And there will be M4 over here. So R3 is going to push M4. So M4 by M1 plus M2 plus M3 plus M4 divided by, so multiplied by F. So this is how you find the reaction forces. So this shortcut is only applicable when F is acting in one direction. Okay. So you can see that the reaction forces, if you can compare, for example, if you take M1 equal to M2 equal to M3 equal to M4, what is going to happen? So A becomes F by 4M, and R1 becomes what? 3M F by 4M. That means 3 by 4F, right? 3 by 4F. R2 will become what? 2 by 4F, that is equal to 1 by 2F. And R3 will become F by 4. So you can see the reaction forces will be like R1 will be, I don't want to put like that. R1 is greater than R2 is greater than R3. This will be the relation if the masses are equal. If it is like in the increasing order, M1 is greater than M2 is greater than M3 is greater than M4, you try to find this thing. Okay, this is for your thought exercise, thinking exercise. So what will happen to the reaction forces if the masses are in this order? Okay, so that's all for today's class. We will continue laws of motion in next lecture 6 2. Thank you very much.